This is the lesson for the first assignment in quiz 5 for the second trimester in Algebra 2. So you're going to want to have some equipment as you do this, maybe a little straight edge of some type to put in your asymptotes on the graph. You're also going to want to have this handout to just read at the particular place when necessary. So it's great if you read this whole thing, but I think as things come up, it's going to be necessary to refer to this document. So we're going to be studying rational functions in this unit. And basically, let me just throw a quick snapshot down here. You're going to have graphs that look like this, where you're going to see a horizontal line where the graph will get closer and closer and closer to that horizontal line. We call that a horizontal asymptote. And sometimes that line is the x-axis. Also, we're going to have a vertical line that we're going to call the vertical asymptote, and the graph will get closer and closer and closer to that, and there's going to be ways of finding these features on the graph. Sometimes that vertical asymptote is the y-axis. Anyway, so this is just about, following a procedure, checking on, your little recipe guide there to see what you need to do. And then once you get all this done, you graph it, and then you find the domain and range, which is really pretty easy to do. You just strike out all the horizontal and vertical asymptotes and also the point discontinuities. So this looks difficult. It's really not. If you'll just read and follow directions, this becomes very simple. So here's our first function, and number one is going to be drawing on something that we've done before, factoring. So the numerator and denominator will not factor, but there's 9 times out of 10, it's going to. So get ready to do that. So number 2, find all vertical asymptotes. So after canceling identical factors, you're going to take the denominator, set it equal to 0, and then solve. How easy is that? That's going to be where you draw your vertical asymptote through. Horizontal asymptote, okay, if it exists. So what do we look for here? So at number 2, any factors that are still left after we cancel factors, you set them equal to 0, you solve for x. What about horizontal asymptotes? This is the hard one in the end, because there are really 3 different possibilities. And this is step 3. So determine if a horizontal end behavior asymptote exists in the form of y equals, to find the equation for the horizontal asymptote when the highest powers are the same. So this is the most common, divide the leading coefficient. So that's the case in this problem. When the highest power in the denominator is greater, the horizontal asymptote is 0. That's the second most common type. And then when the highest power in the numerator is greater, a horizontal asymptote does not exist. So you need to look at the highest power terms. So the highest power terms are x and x. So there's going to be a horizontal asymptote. Let's say the highest power was 2 in the denominator and 1 in the numerator. It was like x squared down here. The horizontal asymptote would be 0. Let's say the highest power was 2 in the numerator and 1 in the denominator. There's an x squared up there. There would not be a horizontal asymptote. So basically what we're doing is we're dividing the coefficients when the powers are the same. We're dividing the coefficients. So your answer is going to be y equals some number other than 0. This is this case. Y equals 0. Okay, so if the denominator has a higher power, or there is not one, if the numerator has a higher power on the highest powered x term. So you need to check that out. Find all point discontinuities if they exist. There are none in this. So what is the point discontinuity and when would we have it? So you got to look here, find any point discontinuities, holes in the graph. Most likely, and it will be in our cases, wherever factors cancel, there will be a hole in the graph. So we had no canceled factors in this. Most of the time you will. Set the canceled factor equal to 0 and solve for x. This is the x value of the hole in the graph. To get the y value, substitute the x value into the expression that is left over after canceling has happened. So when this happens, we'll refer to this. Okay, so you just need to come to where you are on this list. Find the y-intercept, and sometimes it doesn't exist. Most of the time it does. So you're going to let x be 0. This is universal. Okay, so when we do that, we get -3 over -2. And that is 1.5. Find all x-intercepts if they exist. So again, take this out. You're going to have to read this often. Number 6, after canceling identical factors, find the x-intercepts. So we have done that because there hasn't been any. Set the factors in the numerator equal to 0 and solve for x. So the factor in the numerator is x minus 3. That gets set equal to 0. We solve for x and we get 3. Okay, find any oblique. So here's a third kind of asymptote. So this would be a, if you had a slanted line that the graph would get close to. Because these are a lot less important, you're not going to have, I will alert you to the fact when you have these. And again, you can read up the power in the numerator has to be 1 exceed the, so the highest power in the numerator exceeds the highest power in the denominator by 1. And the denominator has an algebraic factor after canceling. I will alert you to where and when that's going to happen, and I'm sure that it's going to happen in this assignment. I'll look ahead here momentarily. So there is none here. Basically, why? Again, because the highest power, so the power on each term is x to the first. So the highest power in the numerator is not 1 greater. So you have to read through all of that. Once you have all of that, you'll be good to sketch. And let's just take a peek here while I'm thinking about this. Don't know if I threw any oblique asymptotes in. There are none. So I will alert you to that. I'm including it on the list, but they're just not very common, but it is part of the show. So x equals 2, we're going to draw a dashed line. Make a dashed line because it's not part of the graph. It's just an imaginary boundary that the graph gets really close to. And then y equals 1. So this is going to affect the domain and range. So if the graph never crosses these, that means we need to take them out of the domain and range. So y equals 1, horizontal, x equals 2. And then from there, put in the asymptotes. I'm sorry, put in the intercepts. So 3 and 1.5. And then if you want, so they're going to be these branches. You can take a look in your calculator at the graph, and they're going to keep getting really close and close and closer each time. And for the most part, although not all the time, you're going to get these 2 branches that look like this. So there will be some where that's not the case. But for the most part, you'll get this. Then you have to answer the domain and range. So you're going to start with all reals. So I use this. X is an element of all reals, formal mathematical writing there. So you can just use the R, but you have to exclude the vertical asymptote and exclude the horizontal asymptote. And if there is a point discontinuity that's coming up, you have to also exclude it. So basically you're looking on 2, 3, and 4. 2, 3, and 4 affect the domain. 2 affects the domain, 3 affects the range. The x value on 4 affects the domain, the y value on 4 affects the range. So that's problem 1. Aha, problem 3, where we have to do a little factoring and canceling, and there's going to be a hole in the graph. So step 1, we need to factor And I'm going to make the factoring super simple and expect to see one of the factors in the denominator the same as one in the numerator. So you need to show that work before you start. It's really, really very important. Okay, number 2, find all vertical asymptotes. So this is where you take the x plus 1, only the x plus 1, and you solve for x. It's after canceling. Find any horizontal asymptote. So the horizontal asymptote is 0. So you have to read, this number 3 is the hardest one because there's 3 possibilities. So it's not the first one. Okay, it's the second one when the highest power in the denominator is greater. The horizontal asymptote is 0. So if you don't see an x in the numerator, but you do in the denominator, it's 0. Or you could just look back here. I have an x squared and an x. So you can do it before or after canceling. It doesn't matter on the horizontal. Find all point discontinuities. So we've got them now. So the first thing you do is you take the x or the factor that you canceled and you solve for x, -4. So that's the x part of the point that's going to be taken out. And then you substitute it in to what's left over. So this is -3 on the bottom. So -4, -1/3 is the point. And believe it or not, you actually can get these to show when you graph, but you got to put the original, and here's the big kicker when you do this. You've got to always put in the original. I'm going to do zoom integer. Okay, so let's see it here. Right there, number 8, zoom 8. And maybe zoom in here one time. It will show it. Okay, not succeeding so well here. Usually it shows it. We'll have to do another one where I can get it to show. But zoom integer does it. I guess you can kind of see it. Let me zoom my camera in right there after 80 tries. So you actually can see it on the graph. Don't try to do what I just did. It's a waste of time. But it actually does show it. And what you also need to know is the vertical asymptote at -1 and the point discontinuity at -4 show up as errors on your table. And then, of course, the y-intercept is at 0. And the x-intercept is when y equals 0, which there's not an x-intercept here. You'll find that out. So there's always ways of finding out on the table these things. Find the y-intercept. So this is where you let x equal 0. And so when we do that, we get 1/0 plus 1. So y equals 1 is that. Circle all the stuff here. Find all x-intercepts. There are none. So how do we know that? Well, set the factors in the numerator equal to 0 and solve for x. X-intercepts do not always exist in rational functions. If the numerator is a constant, there will be none. So there are none because the numerator is just 1. There's no x factor to set equal to 0. And you have to go after canceling with that. Okay, find oblique. So here's the deal. Here's another thing that's really easy. If you have a horizontal asymptote, there's not an oblique, automatic. So there has to be no horizontal asymptote to be an oblique. the vertical is separate. But just know that in your comings and goings with this. Okay, so what does the graph look like? And you can always, I advise that you take a little peek on the calculator. So here's -1, and you want to put in 3, 4, -1/3, just the where the hole exists. Okay, so read that through again. How did I get that? That's important that you know when they exist and how that comes about. And then the y-intercept is 1. Get all of that stuff labeled on there, and then you're ready to sketch. And it's these 2 branches most of the time. And the x-axis, which is y = 0, is the horizontal. So I should have said that up here, x-axis. Whenever you get that, it's the x-axis. So that's the pick of the graph of this. So domain and range start with all reals, and then exclude the vertical asymptote, and exclude the x value of the point discontinuity. And then with the range, exclude the horizontal asymptote and the y value. So you'll have 2 points each when you have a point and a vertical asymptote. Yeah, well, I should say when 2, 3, and 4 are all there, you've got 2 each. Okay, if 4 is not there, you'll just have 1 each to exclude. Okay, and that takes us to number 5. So the difference here is you have to factor both the top and the bottom, and then apply all the same sets of rules by reading through that list very carefully. So this will factor as x + 4 times x - 3. Again, the factoring is, I'm going to make it very simple, times x + 1. And then this will cancel down into x - 3 over x + 1. So whenever you cancel those identical factors, again, you are going to have a point discontinuity. Find all vertical asymptotes. You just take the factor that's left in the bottom equal to 0. Find all horizontals. So this is the case where the powers are the same. So you can, do x squared over x. You're basically dividing the coefficients. So like if this said 2x over 3x, you're going to divide 2 over 3. That's just when the powers are the same. If the power's greater in the numerator, you don't have a horizontal asymptote. If the power is greater in the denominator, the horizontal asymptote is 0 or the x-axis. So make sure that you're following that. Find all point discontinuities. So again, we canceled x + 4. So -4. And then we're going to take -4 into what's left over, into that. So this is -7 over -3, 7/3. And you're going to get an awkward y value most of the time. Get ready for that. Find the y-intercept. So let x be 0. Okay, so then y will be -3 over -4. 3/4 or 0.75. Find all x-intercepts. So we're just going to, after canceling, take the factor equal to 0. So almost always we deal with after canceling, and the only thing we deal with on the canceling is the point discontinuity. But almost everything happens after canceling. Okay, find any oblique. There are none. Remember, that's a very special thing. If you have a horizontal asymptote, you do not have an oblique. Okay, so we're ready to draw. And looks like we'll start off with -1. Remember, the asymptotes are not part of the graph. They're just a boundary. And then 1. And then you're going to put 3 other things in after the asymptotes. You're going to put the intercepts. So 3/4. And then 3. All right, sorry about this. My y-intercept is messed up. So it's -3/1. And I knew it was messed up once I started doing my graph. It could not be. So the y-intercept is -3. 0 goes in for x, -3/1. So that takes me down to -3 down here, and this is not part of the graph. So you know that the graph happens in these branches, and that on this branch, there's no way that it could have been up there and that could have worked. And then the point discontinuity, -4 and 2 1/3. And then 2 1/3, so right about here. So you're going to have this branch like this, going through the point. And again, you could get it to show on the calculator. I'm not going to be big with that. The more important thing is, can you recognize all these features on the table? That's the more important thing. So domain, x is an element of the reals. We want to take out the vertical asymptote and the x value of the domain. Make sure you put not equal to. And then y, an element of the reals. And we want to take out the horizontal asymptote. That is 1. And then the y value of the point discontinuity. So again, you can get all these to show. You have to put in, and we'll just do this real quickly. You have to put in the original guy. Plus 5x plus 4. Make sure you use parentheses. You can use the fraction input thing also. That's really what you should be doing. So we should expect to see at -1 an error. That's the vertical asymptote. We should also see at -4 the point discontinuity, an error. That's why we have to figure out the y, because we don't know where it happens. The horizontal asymptote, you cannot tell on the table. That's the only thing. The y-intercept, 0, 3, there it is. And then the x-intercept is all right, so now that I got this centered in right, I've been making mistakes all over this video. -12, and then x squared plus 5x plus 4. Let me go here again. Okay, so at -1, you should see a vertical asymptote and error. -4, the point discontinuity error. Notice it doesn't show the y, because that's why we have to calculate it, because it doesn't show the y. This will not show the horizontal asymptote. It will show everything else. Then at 0, -3, there's your y-intercept, and then at 3, 0, there's your x. You must see all of this on the table. You must. So notice as I went to 3 and I didn't see y = 0, something is wrong. You got to go back. Okay, so the only thing it won't show is the horizontal asymptote, and in the end, that's probably, you really have to read to figure things out. So that is the first assignment for quiz 5 in the second try.